Google has just revealed something that's reshaping the entire software engineering industry. At a recent conference, the company announced that artificial intelligence now writes 75% of all new code being created within its walls. This isn't a distant prediction or theoretical possibility. This is happening right now at the world's largest technology company, affecting over 100,000 engineers. The shock value of this announcement cannot be overstated. Just months ago, we were hearing about 50% AI-generated code. The jump from 50 to 75 represents not merely an incremental improvement, but an exponential acceleration that signals a fundamental transformation in how software gets built. The announcement came directly from Google's leadership during the Cloud Next conference, establishing it as an official, verified commitment rather than speculation or marketing hype. CEO Sundar Pichai and his team presented these numbers alongside another stunning metric, a claimed six-fold increase in productivity. Imagine accomplishing in one day what previously required 6 days of work. That's the scale of optimization we're discussing. But the real story extends far beyond the raw statistics. What makes this announcement particularly significant is the context surrounding it. Just weeks before Google's revelation, Snap had announced that 65% of its new code was being generated by artificial intelligence. Google's 75% figure doesn't just exceed Snap's achievement, it accelerates the pattern dramatically. We're witnessing a trajectory that's moving faster than anyone predicted. This is the moment the industry stops debating whether AI will reshape software engineering and starts grappling with how quickly that reshaping is already underway. The numbers alone don't capture the true magnitude of the shift. Google is talking about a fundamental reimagining of what engineers actually do. In the traditional model, engineers write code. That's their primary function. They sit down, they think through problems, they translate those problems into instructions the computer understands, and they write thousands, sometimes hundreds of thousands of lines of code. That entire process is changing. Engineers are now becoming what industry observers are calling AI orchestrators. An AI orchestrator is fundamentally different from a code writer. Instead of creating code from scratch, orchestrators direct artificial intelligence agents. They set parameters. They validate results. They make judgment calls about what the AI has produced. They focus on architecture and strategy, while artificial intelligence handles the execution. It's the difference between a chef preparing every single dish in a restaurant and a head chef directing a kitchen staff to execute a culinary vision. This distinction is crucial because it immediately raises questions about employment, skills, and the future structure of technology companies. If artificial intelligence is writing most of the code, what happens to the thousands of junior engineers whose primary responsibility has been writing code? What happens to engineers whose specialized skill was writing reliable, efficient implementation code? Are they becoming obsolete, or are they evolving into different roles? The acknowledgement from Google matters here. Well, they're not claiming they're replacing engineers. Sundar Pichai's messaging emphasizes transformation rather than elimination, but words matter less than reality. When you reduce the amount of routine coding work from 100% to 25%, you fundamentally alter the engineering job market, whether you intend to or not. The implications ripple outward immediately. Other technology companies will see Google's announcement and recognize a competitive threat. If Google can accomplish more with fewer human hours devoted to code writing, competitors must adopt similar tools or face a productivity disadvantage. This isn't a speculative scenario. This is straightforward competitive economics. We're at an inflection point. The question that matters now isn't whether AI will transform software engineering. Google has already answered that question with data. The questions that remain are about speed, scope, and adaptation. How quickly will the industry move toward these ratios? Which roles will emerge as essential in this new environment? And perhaps most importantly, who will successfully navigate this transformation? Before we continue, subscribe to the channel and tell us in the comments where you are watching from. We're tracking this story globally. The productivity explosion reshaping Google's engineering operations demands careful examination of what those numbers actually mean in practice. When Google claims a six-fold increase in productivity, this represents more than a minor efficiency gain. This figure emerges from comparing traditional engineering timelines against current AI-augmented workflows. A feature that once required 2 weeks of concentrated engineering effort now materializes in roughly 2 days. A bug fix that previously consumed 3 days of debugging now resolves in several hours. These aren't theoretical projections drawn from laboratory conditions. These are measured outcomes from Google's internal systems processing real code at scale across its vast engineering organization. The scale of implementation makes this particularly significant. Google employs over 100,000 engineers distributed across multiple continents, working on projects ranging from cloud infrastructure to artificial intelligence research itself. When the company reports that 75% of new code is AI generated, this statistic represents trillions of lines of code flowing through their systems monthly. The computational infrastructure required to generate, validate, and integrate this volume of AI-produced code at quality standards acceptable for production systems demonstrates technological maturity that transcends experimental status. The trajectory leading to this moment reveals an accelerating pattern across the technology industry. Snap's announcement of 65% AI code generation served as a benchmark just months earlier. Now, Google has surpassed that figure by 10 percentage points in what appears to be a compressed timeline. This escalation pattern suggests that the industry is experiencing exponential adoption rather than linear progression. When percentages climb from 50 to 75 in mere months, the mathematical implications point toward even higher adoption rates in the near future. Industry analysts are already speculating about 80 or 90% thresholds arriving within the next 12 to 24 months. Understanding how these systems actually function reveals why the productivity gains are so substantial. Google's internal AI coding systems don't generate random code snippets hoping something works. These systems are trained on the company's entire code base, its specific architectural patterns, its coding standards, and its domain-specific requirements. When an engineer articulates a requirement or describes what a particular function should accomplish, the AI systems can draw from millions of examples of how similar functionality was implemented elsewhere in Google's infrastructure. The AI generates code that aligns with existing patterns, maintains consistency with established conventions, and integrates smoothly into the broader system architecture. The integration with existing development workflows is seamless in ways that earlier code generation tools were not. Rather than forcing engineers to adopt entirely new processes, Google's systems embed AI code generation directly into the tools engineers already use daily. When an engineer opens their development environment, the AI systems work alongside them continuously, suggesting code completions, generating entire functions based on comments or partial specifications, and handling repetitive implementation patterns automatically. This ambient integration means productivity gains accumulate without requiring engineers to consciously think about using the tools. Market context amplifies the significance of these announcements. The technology industry has experienced persistent talent shortages for years. There simply aren't enough experienced engineers to fill every role that technology companies need filled. This scarcity creates competitive pressure that drives salaries ever higher and makes it difficult for organizations to scale their engineering teams as rapidly as business demands require. Artificial intelligence code generation addresses this bottleneck directly. By dramatically reducing the amount of human effort required to produce functional, tested, production-ready code, companies can accomplish more with their existing engineering teams. The competitive imperative cuts both directions. Companies that master AI-augmented engineering gain a structural advantage over those that don't. They can ship features faster, respond to bugs more quickly, and scale their engineering output without proportionally scaling their headcount. For technology companies locked in relentless competition for market dominance, this advantage translates directly into business outcomes. Conversely, companies that lag in AI adoption find themselves at an accelerating disadvantage. Their engineers work slower, their features ship later, their capability to respond to competitive threats diminishes. This reality ensures that Google's announcement will trigger urgent evaluation and rapid implementation efforts across the industry's largest companies. Sundar Pichai's statement at Google Cloud Next crystallized what the industry had been sensing but hadn't yet acknowledged explicitly. The Google CEO framed this transformation not as replacement but as augmentation. Engineers aren't disappearing, their function is metamorphosing. The shift from writing code to directing code-generating systems represents a fundamental recalibration of what engineering means. When Pichai emphasized the 50 to 75% escalation within months, he was signaling that this transition wasn't gradual, it was accelerating. The trajectory itself had become the story. Understanding how this system actually operates in practice reveals why the performance gains are so dramatic. Google's internal AI doesn't function as a simple autocomplete tool that occasionally guesses what comes next. These systems are architectural partners embedded directly into the development process. When an engineer describes what needs to happen, the AI generates not just code, but thoughtfully structured implementations that align with Google's specific conventions, architectural patterns, and infrastructure requirements. The AI learns from millions of internal examples, understanding not just syntax but intent. It recognizes that certain database patterns are preferred, that particular error handling approaches are standard, and that specific optimization techniques match Google's infrastructure philosophy. The validation layer distinguishes Google's approach from earlier code generation experiments. Raw AI-generated code without human review would introduce instability and security vulnerabilities at massive scale. Instead, Google's framework positions engineers as architects and validators. They examine the AI's output, verify it solves the stated problem, confirm it doesn't introduce technical debt, and ensure it integrates smoothly with existing systems. This creates a feedback loop where engineers maintain quality control while the AI handles the mechanical implementation work. The engineer's cognitive load shifts from execution toward judgment and architecture. The real-world implementation reveals which tasks AI handles best and where human expertise remains irreplaceable. Routine functionality that follows established patterns gets generated automatically. API integrations where the contract is clearly defined get implemented by the AI with minimal human direction. Well-defined algorithms that appear elsewhere in the codebase get reproduced efficiently, but complex architectural decisions still require human deliberation. Security-critical code still demands rigorous human review. Problems that don't fit existing patterns still require engineer creativity and judgment. The division isn't replacement, but rather a careful sorting of what machines do efficiently versus what humans do effectively. This implementation model creates the conditions for the six-fold productivity multiplier Google claims. An engineer who previously spent a full day writing, testing, and debugging a feature now prompts the system, validates the output, and addresses edge cases in perhaps 2 hours. Across Google's engineering organization, this translates into staggering aggregate time savings. Features that once required weeks of concentrated effort now move through development in days. Bug fixes that demanded debugging marathons now resolve in hours. The time freed up doesn't disappear. Engineers redirect that capacity toward higher leverage work, architectural refinement, performance optimization, security hardening, and strategic problem solving. The organizational ripples from this shift extend far beyond individual productivity gains. Teams can now tackle more ambitious projects without proportionally increasing headcount. A team of 10 engineers using traditional development practices might handle 50 features annually. The same team augmented by AI code generation might handle 150 features. This scalability advantage compounds across organizations. Companies that embrace this transformation can accomplish more without the corresponding increase in salary expenses and recruitment challenges that adding headcount requires. The psychological dimension of this transition deserves attention. Engineers who have spent careers learning to write elegant code fast sometimes experience this shift as diminishing. Their hard-won expertise in syntax, optimization, and implementation detail suddenly feels less valuable when an AI system handles those tasks competently. Yet simultaneously, the highest value engineering work, architecting systems, making design decisions, solving novel problems becomes more accessible because routine work gets automated. Engineers can focus on the intellectually challenging aspects of their craft rather than the mechanical repetition. This reframing of engineering work from execution to orchestration isn't negative for engineers who adapt. It's actually liberating for the truly talented ones. The transformation unfolding inside Google's engineering organization reveals something uncomfortable that the industry has been reluctant to articulate openly. The bifurcation of the engineering job market is already happening, and the 75% figure serves as evidence that this isn't a theoretical concern for some distant future. It's a present reality reshaping career trajectories across the technology sector. The market is splitting into two distinct tiers of engineering positions. The first tier comprises engineers who evolve into what might be called AI orchestrators or architectural leaders. These professionals command the highest salaries, exercise the greatest influence, and spend their time designing systems, making critical architectural decisions, and directing AI agents to handle implementation. They're the strategists who understand not just what code needs to exist, but why it needs to exist in that particular form. This tier will likely expand, offering accelerated career growth and increased compensation for those with the right skill sets. The second tier faces a more precarious situation. These are the execution coders, the developers whose primary value came from their ability to write bug-free code quickly and reliably. The junior engineers who built their expertise through years of hands-on coding practice now find that the specific skills they developed are precisely what AI systems now handle competently. This doesn't necessarily mean job elimination, but it does mean career stagnation for those unwilling to evolve. The comfortable path of steady technical growth through increased coding proficiency has been closed off. The only direction forward involves retraining toward architectural thinking and AI direction. A crucial distinction needs clarification regarding what the 75% metric actually represents. Google's statement specifies that AI generates 75% of new code, not 75% of engineering work. The difference is substantial. Architectural decision-making, system design, code review, testing strategy, deployment planning, and security validation remain deeply human activities. What's being automated is the mechanical act of translating architectural intent into functioning code. The cognitive work of understanding what systems should do, how they should interact, and whether they solve the right problems remains in human hands. This specificity matters because it reveals where the real transformation happens. Engineers aren't being asked to stop thinking, they're being asked to stop executing the thinking they've already done. An engineer who spent 8 hours daily writing code now spends perhaps 2 hours prompting AI systems and validating their output, then 6 hours on architectural refinement, optimization, and strategic problem solving. From one perspective, this is a reduction in coding labor. From another perspective, it's liberation from mechanical repetition toward higher value work. Inside Google's operations, this reality is already embedded in workflows. Senior engineers have adapted to this environment. They've learned to think in prompts and validation rather than in line-by-line coding. They've trained themselves to review AI output quickly, spot logical errors, and catch edge cases that automated systems miss. They've reorganized their mental models around direction and oversight rather than hands-on implementation. The transition was uncomfortable, but most adapted successfully because they recognized the productivity gains were real and undeniable. The question that cascades through the industry is whether similar adaptations can occur at scale across companies with different cultures, training programs, and competitive positions. Google has advantages that other organizations lack. They have vast internal code repositories that their AI systems can learn from. They have the engineering talent to build sophisticated code generation tools. They have the organizational scale where even marginal efficiency gains translate into massive aggregate benefits. A smaller company implementing similar systems might see smaller percentage gains or face different technical challenges. The uncomfortable truth is that not every engineer will adapt successfully. Some will resist the shift from coding to orchestration. Some will lack the architectural thinking skills necessary to direct AI effectively. Some will find that their particular specialty becomes less valuable as AI systems improve. The market transition will be messy, with some engineers thriving under the new paradigm, while others find their career trajectories disrupted. The organizations that navigate this transition skillfully will emerge stronger. Those that mishandle it may face talent exodus and reduced competitiveness. The bifurcation pattern reveals itself clearly when examining how different engineering organizations are responding to this shift. Companies racing to implement AI code generation systems face a critical decision point that determines their competitive trajectory. Those moving quickly gain access to the productivity multiplier before market saturation occurs. Those hesitating risk falling behind as competitors hire the most adaptable engineering talent, creating a talent consolidation effect where the strongest firms grow stronger while others struggle to maintain capability. The skill transformation required isn't trivial, and therein lies the real competitive advantage. An engineer who masters prompting, delegation, and validation of AI-generated code becomes exponentially more valuable than one who simply writes code faster. This sounds counterintuitive until you recognize that prompting requires deeper understanding of system architecture. You can't effectively direct an AI agent to solve a problem without understanding the problem completely. You can't validate generated code without comprehending why that particular solution works. The skills demanded are actually more sophisticated than pure implementation. This is where the market bifurcation becomes self-reinforcing. Engineers with strong architectural thinking adapt quickly to AI-augmented workflows. They understand systems deeply enough to prompt effectively and validate results rigorously. Their productivity increases compound because they're no longer constrained by typing speed or implementation time. Meanwhile, engineers whose expertise was primarily in execution mechanics face steeper relearning curves. The gap between top and middle performers widens because the tools amplify capability rather than equalizing it. For individual engineers considering career strategy, the calculus is straightforward. 3 skills now matter more than anything else. First is prompting ability. which means understanding how to specify problems clearly enough that AI systems can solve them correctly. Second is validation capability, which requires deep enough knowledge to spot logical errors, edge cases, and architectural misalignments in generated code. Third is architectural thinking, the ability to see systems holistically and make decisions about how components should interact. Engineers who develop these three competencies find their career opportunities expanding regardless of what happens to traditional coding roles. The uncomfortable reality is that some specializations are becoming redundant faster than others. Developers who built careers on mastering specific frameworks or languages face particular challenges because AI systems now handle framework-specific knowledge remarkably well. An AI system can generate Rails code or React components as competently as experienced developers, but these same systems struggle with decisions about whether a particular architectural approach makes sense for a specific business context. They can't evaluate trade-offs between scalability and maintainability without human guidance. This dynamic creates a floor beneath certain engineering roles while removing protections from others. Companies are beginning to restructure their engineering organizations to reflect this reality, though most aren't discussing it publicly yet. The trend is toward flatter hierarchies, with larger responsibility scopes for senior engineers who become AI directors and smaller teams of mid-level engineers focused on specialized domains. This structure reflects where human judgment remains essential. You need fewer people writing code if AI handles implementation. You need more leadership capacity directing complex systems because each leader can now oversee larger technical scope. The market pressure driving this change is relentless. Companies that maintain traditional engineering structures with the same ratios of senior to junior to mid-level engineers will see their costs per unit of productivity increase over time as competitors implement AI-augmented workflows. Within 3 to 5 years, the productivity gap between optimized and traditional organizations becomes untenable. This timeline pressure means organizations can't gradually transition. They must reorganize rapidly or accept diminishing competitive position. The narrative of this transformation at Google serves as a harbinger for the entire industry. What Google announces today, other organizations implement tomorrow. The 75% figure didn't emerge from some unique capability Google alone possesses. It emerged from systematic optimization of tools and processes that other organizations can replicate. The differential will be in execution speed and organizational willingness to restructure around the new paradigm. The companies that move fastest gain the greatest advantage because they access the best talent before the market equilibrates and because their productivity gains compound before competitors catch up. The pattern becomes undeniable when you step back and examine the trajectory. Snap announced 65%. Google announced 75%. The progression isn't linear, it's accelerating. Within months, the percentage jumped 10 points higher, and the velocity of adoption continues increasing across the industry. This acceleration pattern suggests that the next major announcement from a Tier 1 technology company will likely reveal 80% or higher. The timeline is compressed. What once might have taken years to achieve now happens in quarters. The bigger shift extends far beyond code generation percentages. The entire paradigm of software engineering is transforming in real time. The traditional hierarchy that separated junior developers from architects is collapsing. Organizations that previously needed pyramids of junior coders writing implementation code now need flatter structures where senior engineers function as AI directors, orchestrating the work of multiple AI agents simultaneously. The ratio of engineers required per unit of software production is declining, but the capability of each engineer is multiplying. This isn't a simple efficiency gain, it's a fundamental restructuring of how technical work gets organized. The job evolution framework clarifies what happens next. Some engineering roles are being enhanced. Senior architects and system designers find their impact multiplied because AI handles implementation, freeing them to focus on higher level decisions. Some roles are being transformed. Mid-level engineers who adapt quickly and develop strong prompting and validation skills become more valuable, not less. And some roles face genuine risk. Developers whose entire career was built on deep expertise in specific frameworks or languages discover that AI systems now match their capability. The market will sort these categories over the next 3 to 5 years. The uncomfortable truth demands acknowledgement. This transformation is happening inside Google right now, not in some distant future. The 75% figure isn't a prediction or a goal. It's a measurement of current reality. The scale is already massive, affecting hundreds of thousands of lines of code daily. The speed is already accelerating, with productivity gains compounding month after month. The adaptation timeline is compressed for the entire industry because companies cannot gradually shift. They must reorganize rapidly or accept diminishing competitive position relative to those who move faster. What comes next is predictable based on the pattern. Announcements from Meta, Microsoft, and Amazon will follow within months. Each will reveal similar percentages, likely trending towards 70 to 80% within the year. New role titles will emerge officially. Prompt engineer and AI architect will appear in job postings as legitimate career paths. Educational institutions will struggle to keep pace because university curricula lag behind market reality by years. Meanwhile, practical training systems will emerge to help experienced engineers transition their skills. The transition will be turbulent for those unprepared and energizing for those who adapt. The key principle underlying everything is this. The question is not whether this happens, it's how fast. Speed of adaptation determines competitive position, career trajectory, and organizational viability. Skills matter infinitely more than credentials because the landscape shifts too quickly for traditional certifications to keep pace. Continuous learning becomes non-negotiable, not aspirational. Engineers who treat AI systems as junior employees to be trained and directed rather than as threats to be resisted will thrive. Those who resist or pretend the shift isn't happening will find themselves increasingly marginalized. The narrative of this transformation at Google serves as a harbinger for the entire industry. Google's announcement is the acceleration signal. What Google demonstrates today establishes the template others follow. The 75% figure will become the baseline expectation within 2 years. Organizations maintaining traditional engineering structures will discover their cost per unit of productivity rising relative to optimized competitors. The pressure is relentless and compounding. The market rewards speed and punishes delay with remarkable efficiency. This is the threshold moment. The shift from theoretical possibility to measurable reality happened at Google and is now spreading outward. The industry stands at an inflection point where adaptation becomes mandatory rather than optional. The future of software engineering isn't uncertain. It's already here, distributed unevenly across organizations that have chosen to embrace it and those still adjusting to the reality of what's possible.